Using SOLIDWORKS has allowed us to move from concept to scalable reactor production faster and with more confidence. At UpCatalyst, we transform industrial CO₂ into valuable carbon materials with the help of SOLIDWORKS. Unlike conventional methods with a high carbon footprint, our process uses CO₂ as a feedstock and runs at lower energy levels. This means we can produce carbon-negative materials at low cost, helping industries reduce emissions while creating high-performance products. We founded UpCatalyst with a bold vision: to give CO₂ a green purpose. From the very start, SOLIDWORKS has been a core part of our engineering workflow, from reactor design to custom-built gas handling and purification systems. The core technology we use was originally developed by NASA to produce oxygen on long-duration space missions by splitting CO₂. But instead of focusing on the oxygen, we saw untapped value in the carbon it leaves behind. We realized that this is no longer just a science experiment when potential customers tested our samples and confirmed that our graphite and carbon nanotubes matched the performance of high-end fossil-based materials. Even more importantly, we realized we could produce them at a competitive price. That external validation changed everything. We have had good contact with PLM Group over the past few years. When we joined their startup program 3 years ago, they supported us with discounted licenses for SOLIDWORKS, which was crucial in our early development phase. Using SOLIDWORKS has allowed us to move from concept to scalable reactor production faster and with more confidence. Our team relies heavily on 3D modeling, assemblies and drawing tools to rapidly prototype new cell designs and production modules. The parametric modeling features allow us to test design iterations quickly while maintaining tight dimensional control. In particular, the sheet metal and weldment tools have been valuable for our production infrastructure and mounting systems.
SOLIDWORKS Simulation has been essential for stress and thermal analysis of our electrochemical reactors and support frames. We've used it to model thermal expansion, stress distribution under high loads, and vibration damping in our reactor assembly. This has reduced the number of physical prototypes needed and helped prevent design failures during operation. We also use simulation in our material selection process, especially for parts exposed to high temperatures and corrosive environments.
As we continue to scale, our CAD work will cover more complex and interlocking systems. Designing entire reactor systems in CAD will be a major part of this evolution. We have learned that it is best to design production processes in unit cells that can be reused at larger scales, saving costs and reducing risks as we grow. Beyond the tools themselves, it has been valuable to know that we have a partner we can turn to for support as our needs evolve. As we continue to grow, we are interested in exploring PLM Group's trainings to get the most out of the tools we use every day. Ultimately, we are giving CO₂ a green purpose, turning emissions into essential materials for batteries and beyond.